All right, everyone. Thank you very much for coming. My name is Peter. You might have seen me somewhere on Twitter or my blog on peterullrich.com. I'm a software engineer with Elixir now for 5 years. I was at ElixirConf, gave a talk there about software architecture, I guess. Yeah, that's currently my topic that I talk about a lot. So today I would also like to talk a little bit about, I call it future-proofing your application, but it's just a little deep dive into the Onion architecture, the hexagonal architecture, and their child, the explicit architecture. So what I would like to talk to today about is just to give you a new idea about how to structure your softwares, especially Phoenix or Elixir applications. Because I think that's a topic we don't really talk that much about. And if you just started with a new project, you did like mix, Phoenix, generate, you have a project where you can just add your features to, but then you work on that and you work on that and you work on that, and after a couple of years, everything is a mess. So, to prevent that, what you need is kind of like a plan about how to structure your code base better. And that's what I would like to, I would like to give you some inspiration today for that. So the other day, I wrote a blog article about, I call it Kill Your Phoenix Context. Maybe some of you have seen it. And it was basically, deconstructing the Phoenix context that you get when you create a new context. When you create a new schema in a table, you create a context file, and we tend to just push all the application logic we have into that context file. So it grows and grows and grows and grows, and after a while, it's just a mess. So my article, was about the topic, how can you, first of all, why is it bad to do that? And then also I give some ideas about how to structure it better. And today's talk is a little extension of that, really. So the thing is, when you start a new Phoenix project, if you just, mix, generate new, you get this, basically. You get some controllers and live views, you get a Phoenix context in the middle, and then you get like a persistence layer, Acto, at the bottom. And, you have some calls going from live view basically to the context, for creating stuff or retrieving stuff. And you might also have some calls going from the persistence layer back to the upper layer. For example, if you have PubSub, you broadcast a message. So actually your live view updates, but you in Acto, you broadcast the message. So you have like a two-way communication. And if you have ever read anything about architecture, you probably know that this is called the layered architecture. You can also call it the pancake architecture, or panqueca in Portuguese. And well, this is a very, very common architecture, and everybody kind of has seen it before. At the top, you have the presentation layer, which in our case usually is a live view or a Phoenix controller, or this could also be an API controller. You have the business logic in the middle. If you just generated the project, it's a Phoenix context, and then you have a persistence layer at the bottom. And this is great, for small projects, if you just have small projects really. But then if your company grows or your project grows, this won't work anymore. And if you dive into the layered architecture, you will learn a lot about the pros, but also the cons. Especially, let me just show you something, because this is like your project in the beginning, and then you work on it for like a year, and then your project looks something like this. So at the top, you not only have your controller and live views, you might also have webhooks. If you use any payment system like Stripe, you get a webhook. Hey, somebody purchased something. You might also have an event system. Could be like RabbitMQ or MQTTP or something. Well, then in the middle, you still have your Phoenix context. It doesn't really work anymore, does it? And at the bottom, you not only have Acto, but you also have external APIs. You have the mailer, stuff like that. So at the bottom, it's not like, what I meant is with the driving. Like at the top, you have the things where people interact with. Like you get a click on a button, you get a webhook from Stripe, you get an event from your event system, from your event queue. And these things, they execute something. And so the whole system becomes much more complex, right? And you might even have PubSub. Where do you put PubSub? Because it's kind of like something that's driven, it gets executed in the Acto, down here, but also it's driving. Because if you receive a broadcast here, anyway, sorry, that was a little deep dive. But you see, it becomes much more complex. And yeah, so the layered architecture doesn't really work anymore because the middle layer, the Phoenix context, will just grow and grow and grow and grow. Eventually, it will become a mess. So now I hope you understood a little bit the problem. The question might be, how can we improve this? And I would say, let's design something better, and we can do it together now. So again, this is what we start with. And now the first step that I would like to take is to turn the layers. You know, we had the layers from the top to the bottom, and now we just turned them 90 degrees. Now on the left side, you have the driving actions. Previously, there was a controller live view. It's all the same, but now we just say, well, this is the driving side. So this is inputs into our system. Could be a click, could be a webhook, could be an event. Then you have something in the middle. Right now, it's still a Phoenix context. And then on the right side, you have the driven components of your system. So you have the actor, you know, the persistence layer. You have external APIs, and you have the mailer. So all these, like it's from the driving to the driven side. So now we turned it. And let me do one more step, which is to add a little something. Yeah. All right. So this is the first architecture that I would like to present to you today, because now you have kind of seen how we got there. This is called the hexagonal, or also ports and adapter architecture. And this architecture is really well known for its hexagonal shape. I didn't make it like this, but this is how it looks like. And it doesn't really make anything, it doesn't really change anything to the architecture that we've seen before. Like, you still have the things here, but then between your outside, your external forces, and your internal logic, you put some, you know, little things here. It could be interfaces. You could call them interfaces. The architecture called them ports and adapters. It works really well if you use Java or C# or something where you have interfaces. You know, in Elixir we have behaviors, but they are not really the same as interfaces. So I will just, you know, go through this so that you understand what it means. Then I will dive into the code and I will show you how to code this, and then, you know, hopefully you understand it better. So the hexagonal architecture, it's all about the idea behind the hexagonal architecture is to protect what doesn't change over the long term. Like in the middle, you have your logic, your domain logic. You know, whatever, like for example, you know, you have an e-commerce platform and you sell things. And some things you can't sell to minors. You can only sell them to adults, right? So your user has to be an adult. And that's a law that probably won't change in the next 10 years, right? That you can't sell cigarettes or alcohol to minors. So that is like domain logic that you have to check in your system, and that won't change in the next century, probably. So that is something that is like really important. You know, if you make a mistake there, if you sell to minors, you will have a big issue. So it's really important, and it doesn't really change that often. So that is something that's called domain logic. That is something we put in the middle, and you want to protect it from anything that goes around it, because you don't want to have an age check that is dependent on whether somebody tries to buy your alcohol on the website or, you know, in another system. Like, it doesn't matter where somebody tries to buy something, the logic is always in the middle, and you protect it. All right, so that's the first idea of the hexagonal architecture, to move everything that is important and doesn't change that much into the middle. Now, the second thing is to move everything that changes often and will change in the future to the outside, like to make it as less important as possible. Because we saw when you started with the software, in the beginning we only had a controller in the live view, right? But then over time we added webhooks, we added events. So like on the outside, that's where you add stuff and you take stuff away. And if you move it to the outside, like if you move something like Stripe webhooks to the outside, it means you can easily replace it. Like your system doesn't depend on whether you use Stripe or whether you use Lemon Squeezy or Onion or something else. It's outside, so you can easily replace it. And then on the driven side, it's the same goal. Like right now in the beginning, we have actor, we persist something to Postgres. Okay, that probably won't change. But then we have a lot of external APIs that we interact with. and they will change. And maybe you have a new service that you want to use in your software, or you want to get rid of other services. You know, we have a lot, like you have a lot of it's called a platform danger, I think it's called. Well, if you depend on a platform, what I mean is like you build a software and you might depend heavily on one external system. And if that external system goes away, your whole company is basically fucked, right? And you kind of want to like move this dependency as much as possible away so that you can replace it if anything happens. You know, same idea with like Amazon Web Services, Google Cloud. Like if you can't pay the Amazon bill anymore, maybe you want to move to Google, and you want to have this transition as easy as possible. So you want to make these things replaceable. Anyway. All right, so that's the basic idea. I understand this is all a little complex, but I hope you understand these two things. In the middle, you have the things that don't change. Outside, you have the things that change and that you want to make easy to change. And then in the middle, right now, we replace the Phoenix context with something that we call application service. And I will show you what that means. All right, sorry for this brain dump, but this is just, I will get back to this. So I just want you to understand the theory. And now I will dive into a code base to show you how to implement this. And then hopefully it becomes, more practical. All right, so I have a little website, which is nothing special. I think I have to start it. No, it's still running. Yeah, so it's just a very, I just generated a new project. And this is a website where people can list their houses. Because I'm currently on a house hunt here in Portugal. I would like to buy an apartment. And, this is a website like Idealista, where people can create the listings, and they can create a listing for their house, and they can make it very expensive, and they can say where it is. Just very easy, right? Now, this is just generated with Phoenix. So if we look at the code, what we see is that we have a form component. Yes. Oh, this? The code. Okay. Like this. Yeah. Otherwise, there are also some chairs in the front still. Yeah. All right. I don't want to dive too much into this, but if you ever generated a Phoenix Live system, you see that this here is a form component, right? And you enter it, and when you hit save, basically, this is where you create the listing. It's just a call to your context. It creates the listing in the database, all right? Okay, so what we have here right now is like we have our live view. It calls directly to the context. The context, creates the listing in the database, calls to the database. Nothing special here. All right, now I wanted to tell you how to change this, because now, for example, we want to make it so that we can easily add an API controller to this system. Like, we not only want to create a website, but we also want to have third parties integrate with our API. So we need to have two ways of creating listings. So the first thing that I do, like to move these things outside. So let's first think about. Let me go back to the. So let's first think about this side here, because we started with a live view, and it directly called like the Phoenix context, and that called actor. So the first thing we need to do is put something here in the middle that, like, is in between what changes and what shouldn't change. It's a little abstract, sorry. But what I mean is basically, we're gonna create a simple service like this. And that is if you take away one thing from tonight, it's this. If you want to future-proof your application, heavily invest in services. Like very small services that only do one thing, and that's it. Like every use case. For example, creating a listing, right? This is previously, it was just one call, like listings, create listing. And this was a function in the context, right? But now imagine you want to add something to this. Like when you create a listing, you want to send out emails to people who subscribe to that area. They want to have notifications. You might want to fetch some extra data to enrich the listing. So if I wanted to do that, I would need to write all of this here, or I would need to put it in the context so my context grows. So what I can do instead is I can create a service which encapsulate all of these things that I need to do, that I want to do for when I create a listing. Like in this case, for example, well, first we create a listing. That's fine. You know, we want to have immediately like that thing in the database. Then I will geocode it. I have the address, like Braga, but I don't have the latitude, longitude, so I can't show it on the map, right? So I need to geocode the address into a coordinate, a position. So that's the thing I do next, and then I just update the thing again because I want to store the new location in the listing. All right, and so this service here, that functions as our port, so to say. Like right here, this is where our service lies. And that means we can easily, you know, add a controller that calls the same service, or if we have an event coming in, it could crawl the same service, right? We can add whatever we want here. We can always call the same service, and we can always create a listing, right? So that's already the first step. So basically, where I say port, this is what an application implements this port. So this is called an application service in the hexagonal architecture. Okay. Now the next step is, let's have a look at this side. Because previously, like we called directly actor, for example. Actually, we don't do that all the time. From the context, we directly called actor, we called repo actor and so on. So the next thing that we want to do is to add something there, to add something here so that we might also be able to replace actor at one point. Like if that ever happens, good luck to you. I hope it will never happen. But theoretically, we could change it. You know, we could use something like a Neo4j, like a document-based database if need be. So, and that's very easy to implement because all you need to do is previously you had the context, which had the create, update, delete, retrieve. What you do instead is you create a repository. And that's it. Like this is called the repository pattern. So you kind of have a module that offers the CRUD operations, the create, retrieve, and so on. And that kind of, you wrap around the schema. So you know that already because Phoenix implements it for you in the context, but it doesn't tell you that it does that. But that's it. So basically what you do is like you move all the functions for interacting with the database into like a repo, listing repository. And this way, like your system in the middle here, like if I want to create a listing, well, I call the repo, and the repo calls actor or inserts it into Postgres. But I could replace this thing. Like in the repo, I could not call Postgres, I could call something else. For example, that's handy for caching. You know, like right here, I have my repo and I want to retrieve the latest listing for Braga, like the latest houses, right? That's something I want to cache. I don't want to, for every request, don't want to go to the database, I want to cache it. So in here, you can easily add that, right? In this, basically here, like if we had a list, like listings, all right? And here, for example, for the city, and I could do first like cache X, you know, I'm not sure what the API is here, but like has cache, you know, for city basically. And then that, I retrieve the cache. And else, then I make the listings like this. All right, so this is, I don't know, this is pseudocode. I'm not sure whether it works. But this is, you know, from the outside, all we call is listings. Like that's the function we have in all the rest of our system. And they don't care whether we cache it or whether we get it from the database, right? But inside here, we can decide we take it either from cache or we get to go to the database. So easy. And that also means we can replace cache X with whatever we want. Like the rest of the system doesn't care. So we can use something else here, whatever. So you see that by having a repo over here, we can replace whatever is over there. Like we have actor, but we might also have cache X, might have something different too. And we can replace it. So that's the main takeaway from this architecture, because these external services, everything here and everything there, these external services, they will change over time. But your listings functions that you need to list listings, that will never change, right? All right. And that's true. Yeah, so that is like two things: services, repositories, ports, and adapters, basically. Just try to always have something. If you have a dependency to the outside world, try always to have your own module, your own interface that interacts with the outside, and then only depend on that interface. Okay. All right. Yeah, so this is basically what we have here. Like, this is what I told you. On this side, we have services. On this side, we have whatever adapter. For example, there's another idea here for the geocoding, for example. I have an adapter, to an external service that geocodes my location. And that kind of is like, it looks like a service, might be a service. But, it's another thing where we don't, like, sorry, let me show you the way I use it. Yeah, because I use it here, right? When I create a listing, I geocode it and then I update it. And this here, like, it's another service. The geocode listing is another service. You could, because, sorry, that's another point. But there's another service, so services can call other services, and they do that quite often. And that service then calls the external API through an adapter. So this is our adapter here, basically. And that means, like, from the outside, from the rest of our system, we just depend on the adapter geocode call function, right? This is what we call in the rest of the system. But inside this, we can replace our geocoding service as we want. Because especially geocoding services, they might be more expensive, they might be cheaper for certain use cases, so you might want to replace them quite often. All right, I think I made that point quite clear. On the right side, adapters, left side ports. Now, I told you when I started this talk, I told you that inside the system, like in this place, you want to put whatever doesn't change in the future, like all the most important domain logic you have. And if you do that, it kind of looks like this from an architectural standpoint. Yeah. So the rest is the same, only in the middle. I added two more boxes. And domain model is the most important box here. A domain model, well, it comes from domain-driven design, really, that idea. But a domain model is the idea that you have a thing in your system, like listing or user or even address, and that thing represents, how do you say that? Well, it's a representation of the real-world thing in your code base, like a user, for example. It's a person, right? And you represent that with the person domain model in your database. And then if you have the domain logic, like what I told you earlier about the minor adult thing, where you can't sell to minors, like you can't sell alcohol to minors, but you can for adults, that is domain logic that depends on the user. So it's like the user's logic. I'm not sure whether that's very clear. But let me show you the example here, maybe it becomes more clear. Because we have our listing here, right? This is our listing, and it's a schema, but it's also our domain model. And you have like the regular fields, like address, price, and then you see latitude, longitude, which we add. And then also you have a published add function, where once somebody, like they have a draft, and then they say, okay, now I want to publish my listing, and then it goes out and people see it. Like that's when this happens. But if we want to publish a listing, we first need to check a couple of things, and that's what we do here in this can publish function. That's basically our domain logic. That's what I'm talking about here. Because there's some logic that your product manager or product owner will come to you with, and they will say we should not allow listings to be published if they have an invalid price. In our case, it needs to be at least 10,000 euros, because everything below that might be spam. Or our company doesn't deal with small deals, like we only want to sell big houses, right? So everything below $1 million is not interesting for us. Well, I'm telling you these things, but these are business requirements, right? And you need to put them somewhere in your code, and the domain model is the best place to do that. So in here, for example, I have the minimum price, 10K, and when I want to publish something, I first validate, is the price larger than our minimum price? And if not, I just return an error, say, well, your price is not high enough. Maybe try to be more rich. And And you also need to change some, regular things like that you need for your system, like validate the location, where you just want to validate that the listing has a location. If it doesn't have a location, we can't show it on the map, so we can't really publish it because it misses data, right? And this year you might put in a change set. It's okay if you have, multiple change set, like you could have a published change set, and then here you have validate required latitude, longitude. I'm okay with that too. But to have it like this here also makes it very clear of what you require if you want to publish something. All right. I'm not sure how good I'm on time. Is it still some time? Yeah? Okay. All right. So then because I showed you this, and I just want to make this point more clear. Like inside your system, the hard part here is I show you this diagram and then I show you code, and it's always hard to connect these two, right? So I'm just jumping back and forth. But the idea here is that you have your domain models in the middle. You keep your domain logic as deep inside your system. Like this logic in here should not depend at all about any of these things outside, right? Like again, if somebody wants to publish a listing through the live view, you call the domain logic, and it says no, you can't publish, right? If they come through an API controller, you call the same logic, like you apply the logic to everything. Same with webhooks events. So you know always when you create a listing, you check that the price is correct and there's a location. And that is true for all the things, like for all the listings, wherever they come from. All right. And so what I showed in the middle here, it's basically called the Onion architecture. If you look at other representations, I don't have internet here, that's okay. If you look at other representations, it looks like a round onion with different layers. That's why it's called Onion architecture. I drew it a little bit different. So in the middle, you have the Onion architecture, and then on the outside, you have the hexagonal architecture. And together they're called the explicit architecture. Because you try to make this here, like you have ports and adapters, and in the middle, you have the domain logic and the application services. All right. Just to, as a last example, just to drive home because I see a lot of questions in your eyes still. So let me just show you how I would implement the publish button here, right? Because I have a listing and now I want to publish it, and I'm going to show you the entire stack, like going from live view to the port, to the domain, to the application service, to the domain model, to the adapter, to actor. Okay, the whole flow basically. So we start on the live view, and the live view is very simple. You probably have all seen it. Like I have a button and it sends a publish event with an ID of a listing. And that's it. It gets a listing, and then it calls the publish listing service port, right? So live view port. And the publish listing, the publish listing service, it just checks with the domain model, can this listing be published? If yes, it publishes it. Sorry for my hand. It publishes it, like it adds the publish at datetime, updates the thing. That's it. All right. So it goes to this function, can publish. The domain model checks, is the price okay? Is the location okay? If so, it says yes. Then we update the domain model and we call the repo. So we have been to application service, domain model, and back. Now we call the adapter, which is this one, create listing, done. And then we show the results. Sorry, in here. Yeah. So if it's okay, we insert it. Otherwise, we show error message. That's the whole flow. I mean, I understand this is like a simple flow, but I just hope you understood where you can put certain things. So in this thing, you don't need any context anymore. Like Phoenix context, you can get rid of them, replace them with repositories and services. And just to wrap up, first lesson, use services. If you want to make your application a bit more future-proof, write every use case, like create listing, but also like bigger use cases where users go through a whole flow, where you call create, update, do this, do that, send an email, all of that will be in one service. And these services you can nicely test, perfect. You can remove them if you don't need them anymore. That's it. Second learning, move everything that will change in the future, like technology, move it to the outsides, like metaphorically. Depend on them as little as possible. So always have your own interfaces, your own boundaries between them. Never call like from your from my service, like create listing, this one. Like here, I would never call the geocode service directly in here. I would always call my own interface, which then calls the outside service. So I only depend on my own interface, on my own service. Right. Then just two more things, because these have been things that we have issues with, because you see now in the structure already, I have a lot of services that belong to like selling, my selling domain, everything about selling. You might have buying, geocoding might be another domain. Like you have a team that handles the geocoding, you have a team that handles selling, and you have another team that handles whatever, like data analysis, for example. And if you want to organize your code, I can highly recommend creating first, like in your library, in your lib, you create folders for every domain you have. Not team, but every domain. So something that belongs together. It's another topic. And then eventually in these, you will have like all these things, services, repos, and so on. So this also, from a code-based standpoint, you can make it easy to split it into different groups. And then the issue that we're having in my company right now is that now every service calls every other service all over the place. So like selling calls geocoding, calls whatever, and you got a big ball of mud. And that's why not another one last suggestion. If you set up a structure like this, I can recommend having a like here, like you bring back the Phoenix context, but you use it internally. So in here you would have this. Yeah. So in your group, in your domain, you set up a Phoenix context again, and you make it your internal interface, your internal API. And that means that the team or the teams that work with everything geocoding related, they can define themselves which functionality they offer to the other teams in the company. And all the other teams in the company need to go through this module in order to call anything inside the geocoding domain. And that way you can easily see, like, oh, this domain, like selling, calls the geocoding context all the time. Like they're very connected. So maybe we should merge them. But anyway, it makes it much easier to see the dependencies between domains in your system. And I think that's about it, really. I'm sorry this was a little theoretical, but I hope you got some learnings from it. So if you have any questions, I'm here to answer them. Thank you.
Questions?
Yeah. Yes.
You raised that one.
Tom.
So applying the same train of thought to the domain model, as code bases get larger, the job of the domain model is to encode, our knowledge of the domain. But encoding that in code is only one of the choices. Like another choice is to encode it in data. Yeah. So have you? I haven't explored this fully, but I've seen some attempts to try to maybe business process modeling, like to pull out aspects of the domain into a data set that then the domain model code operates on, and that also can expose it, to domain experts that are not coders, and they can make easy changes and things like that, and it's auditability and things. So just to kind of avoid the problem of putting too much logic in code when it might be better served elsewhere. So I haven't explored that, but have you seen that work elsewhere, or have you explored that yourself?
We had, like in my last company, we had a situation. We used Cucumber. So Cucumber is a way It's basically if then else. No, if when then was it? Given when then. Thank you very much. So it's given when then. So you basically write just a text file, and the first sentence starts with given I have this thing, when I press this button, then I expect this result. And this is like very proper business logic. That is what the user expects from the system. And you can write tests with it. You can write end-to-end tests with that. Actually, you can automate that too. We had that. Wasn't that useful, to be honest? Like you can also just write a normal test, like a normal Elixir test, and then have comments like given, when, then, right? So we had that. But yeah, so what I learned is if you have, like, your domain models might become very big at one point. If like one thing like user or person, they have a lot of different domain logic in them. And that also helps, like then it helps to split it up into the subdomains. So like the e-commerce subdomain you have in your system that handles the e-commerce side of things, they have their own personal user domain model that has logic specific to the e-commerce system. And then on the other side, you might have a legal team, or like billing team or whatever, some other subdomain in your company, and they have very different, like they only care about certain rules that are specific for them. Like e-commerce could be, I can't sell alcohol for minors, but the billing team might be, if somebody sells on my platform, they all need to have a bank account associated. That might be like different logics there, so you can split out into different domain models. Yeah, but I haven't fully understood the point with data sets, but maybe I touch on that.
Yeah, I think maybe the best example is like something like BPMN, I think business process modeling notation. Yeah. And then maybe having like some engine that operates on that. So okay. There might be some other examples out there. But that's...
All right. Well, that's my point. I actually gave a talk, 4 years ago, where I presented the cucumber given when then thing, and I told the audience, this is amazing because you can take it and give to your users, and they can read and check it. And then one guy asked, like, well, have you ever done that? And to be honest, no, I've never done that because like only the coders care about the code. The product manager and the users, they care about what the system does, and if the system doesn't do what it's supposed to, well, then you can have all the documentation in the world. It doesn't help you. So, yeah, that's why it was a little overkill back then. Any other questions?
Yeah,
Yes.
My question is probably a bit specific to your example. So if you could go back to the code and show the listing the main model.
Yeah.
Yeah, exactly that. You mentioned that we should separate the Ecto from the, and I see that you have the schema there, so it's connected to Ecto. I assume it's for you to be able to have the struct to be accessible with the same name as listing, but how would you handle that, guaranteeing that you would be 100% removing that part to your adapter? Yeah. And not having it there. For example, we use Neo4j on the other side, and we still want to have the struct. How would you have it?
It's a very good point. Good catch. The point here is like, yes, so you're right. So what I said earlier, like Ecto is also a technology you depend on, right? And like I said, the domain model should be technology free because you might want to replace Ecto for something else. And that's a good point. To be honest, it is a trade-off, and like you can remove Ecto schema here, but then you lose a lot of the validations for types, and also like change that stuff, which is very handy. So and you would also need to duplicate this schema in your Ecto thing, and you would need to duplicate it into your domain model. Like this here could just be a def struct, right? And this would have like an address, a price, and so on. And then you have a listing struct, but you don't have an Ecto schema, right? So either there's a smart way of generating an Ecto schema from a struct, like dynamically. So you tell Ecto, create a schema based on the struct, maybe, I don't know. But to be honest, to answer your question this is a trade-off I'm willing to make, because if I have to remove Ecto from my Phoenix application, I might rather go into the woods and start farming or something.
Couldn't we, like, the Ecto part be like more the database part, and Ecto be more handled like kind of to model that we use the schema just for the change set and the validation, so we can incorporate like Ecto in part of our Onion layer or something like that, and the database itself can be on the outside, like you can select any kind of.
Yeah. Well, this is actually what you have already. So if you look at the dependencies, you see that Ecto is separate from Postgres, right? The dependencies. So you mentioned it's very good. Like I can use Ecto still for having my schema, creating change sets, and even inserting it into the database. But the connection to the database is in this case Postgres, Postgres, which I can replace with something to MySQL or maybe any other adapter to another database. You know, if I wanted to. That's a good point. So. Like this here should maybe not be Ecto, this should be like database connector. Right, that's a good point, thank you. Any other questions?
All the interaction that this causes, because now you need to check the controller, the port, the domain, the adapter. Yeah. Sometimes finding where exactly the code is, doing the actual thing that you want to check, might be tricky with this. How do you handle that?
So you first say, how do you handle the
interaction? Yeah.
Yeah. And with that you mean?
Let's say I'm working on the front end of this application, I'm looking at the controller, and I want to find where the logic that controller is giving me the data from, for example. If I want to check where the data is coming from, I need to know that's coming from the controller, that goes to the port, and then to the domain, then goes to the adapter, then goes to the Ecto.
Why do you need that to know that?
Because I might want to know that. Yeah, sure. I don't need to know, but if I wanted to know exactly where the logic is implemented, if it's not on the domain model, it might be a bit tricky to understand exactly where it is, I guess.
Yeah. Okay. Well, yeah, my point in the beginning was that you actively try to design the system in such a way that you don't have to care about it, right? So the controller here calls your service and that's it. It doesn't care about anything else. It just say create listing and give me a listing back or give me an error back. Okay, I'm happy with either. But then whatever goes on in the background, you want to move it away. You want to make it invisible, right? Because that means you can change your controller, and if you give the right attributes still to your service, everything will continue to work, even if you replace the entire system on the other side.
I'm talking as a developer, not as a consumer of the API. I'm talking as a developer. If I wanted to enter this code base,
right? Okay.
And try to understand exactly where things are.
The point here is like what I learned, because I work now with like at least 4 different architectures. It takes some time to get used to it, but if the other developers who came before you kind of stuck to at least one guideline, it doesn't matter. Like even if it's a bad convention, like if you have a code convention, even if it's a bad code convention, as long as you stick to it, it's much easier to other developers to learn about it. So in this case, yeah, there are many more moving parts, but I'm telling you, like I've said that also before this, like my job is like 90% creating endpoints, you know, like CRUD endpoints, and just like getting data and retrieving data and whatever. And you will have the same, I think, situation here where the controller calls a service, calls the domain model, calls a repo, that calls the database, and that's it. And then you return the whole thing back to the controller. And if you've done that like 10 times, you got it. Yeah. But I agree with you. It is more complex than, you know, the layered architecture, obviously. But there are not that many moving parts in it. Any other questions?
I have a question.
Yeah. Sorry.
Okay. You talked about having kind of like public interfaces for a domain.
Yeah.
That last part you mentioned. In Elixir, like technically, how do you prevent people from other teams to just use whatever from your domain?
Well, yeah, there is no, you know, like Java private functions. Well, there are private functions, but yeah, there's a library called boundary, and it checks it at compile time. So if you make any cross-boundary calls, it just says no, and it fails. Yeah, there isn't a good way of doing that inside Elixir. Maybe there is, but I just know about boundary. Yeah.
I have a question. I think like how software grows, normally one thing that happened to me is that I have a lot of schemas and logic, and they start to interact with each other.
Yeah.
How do you handle that? Because normally, for example, I have a model A, and then I have a model B, and then a model C, and the model A can interact with model C and have joins and proper handling validation stuff for the two models, and then I have model C. And if I want like to keep things more separated, how do you handle that?
That's a good point. Yeah, so what I said earlier also about the domain logic, domain model, like inside we have listing as a domain model, right? And usually a company revolves around a small set of domain models. Like in our case, if we would build Elixir, it would be listing. And then all the teams, like if you have 100 engineers, they all work on that one domain model, and they all join it, and they preload it, and they change it, and whatnot. And that means your schema will grow and grow and grow, because everybody wants to put their fields in the schema. And that's kind of, I think, in that direction what you meant. And that's where domain-driven design comes in, and I spoke about that a month or two ago in Elixir Conf Africa. And there's also a great book, Learning Domain-Driven Design, which talks about this topic really well. So basically what you want to do then is split your domain model into domain models that are specific to the domain you work in. And with that I mean, like we have listing, right? Like we have listing here, but this would just grow as if teams start working with this schema. They need to store their own whatever on the schema, and it would grow and grow and grow. So eventually what we can do is you can separate this listing domain model into, for example, like let's say it was our because we are in the selling subdomain. Like this will be our selling listing or a listing domain model inside the selling subdomain. And now in geocoding we might need the same, and then in here we can create a have a geocoding listing, and we don't care about the price, for example, here, and we don't care about the publish that thing, and so this way you can separate your domain models. You even copy them, same name, but then every subdomain has their own, and they can add their own stuff to it. Also, but if you see that domain model A interacts a lot with domain model B, you might want to merge them, or you might want to separate them.
No, my experience is I don't want to merge them. I could merge them, I could have a unified object, but they're on their own, they have their own value.
Yeah.
So in some endpoints, I want to display model A or model B. In some other endpoints, I want to display the unified.
This way, yeah. So that's a good point. Maybe in Ruby you have the what's it called, the value object, I think, in Ruby. So my point is basically, if it's about the presentation of these domain models,
it's like I think it's both in the presentation, but also like how for example the database database flow queries, how I put them. Do I put in the model A repo, or put in the model C repo, or create a model A and model C repo and put the queries that are binding both of the two models?
Okay. So the question there is like, I have one query and it queries both model A and model B a lot. If it's a complex query, because usually the ones that have multiple tables are complex, in my blog post that I mentioned earlier, I advocate for another thing which is called a finder. And for example here, find latest listings. Find. All right, so if you have very complex queries, like long queries that join things and aggregate things and whatever, you don't really want to have them inside your repo because they're so specific. You have one use case that executes the query and that's it. Nobody else cares about it. It's not like list or get listing or something generic that a lot of people use. So in that case, I advocate, and I made good experiences with having dedicated finder or query modules. And in here, you would write your very complex query. and like where and join, and then you do a select, whatever. Ooh. And then you do a select, and then eventually you do a repo all. Repo all. All right. So this will be, your complex query, and you put it in this module, like find latest listings, for example. And that returns a list of listings, and this one you use only in one service that returns it to the presentation layer, for example. And like by encapsulating very complex queries in these finder modules, you make them really easy to test, because you have one test file, one module file. You don't have like one giant test file for your repo where you test everything. You can easily delete them if you don't need them anymore. You can modify them, because exactly there's only one place that uses it. So that's very nice to just put them in a corner and forget about them. And this way you can also solve that issue. Well, one last point, just maybe read my blog post that I mentioned earlier, Kill the Phoenix Context, because it also touches on these things that I'm explaining right now. Any more questions?
Thank you, Peter.
Thank you.